Hello, my name is Tarek, and in today's lecture, we will continue our work on the code analysis. Today, we will examine some more code and uh, we will see how the code will work, and we will take out their runtime complexity. Okay, so the first code is this one. We have a for loop that starts from 1 and then goes to the n. Now, the interesting part is this one. We are multiplying the value c and then we're storing the value back to the variable I, right? C is a constant. Now the value of c is 2. The value of n is undefined because we do not have any concern with the n, because whatever the value of n is, the loop will work till that value. So the question is, how many times this statement, the name Muhammad, will be printed. So let's see how the code will work. Let me take help from a table, and okay, here we have a table, and let's say we have, here is steps, and here is I equals I multiplied by c, right? So this statement is equivalent to this one here, right? Okay, so on step 1, the value of I is 1. 1 equals to 1, uh, so 1 multiplied by 2, so the value is 2. The I is equals to the 2. So 1 multiplied by 2, the resultant is 2. Okay, at step 2, in second iteration, the 2 will be multiplied by 2 again, right? Because now the current value of I is 2. So we are also storing the value into the I. So uh, the current value of I is 2. Or you can also write it like this, like I equals to 1 multiplied by 2, right, and equals to 2. Now in second iteration, I equals to 2 multiplied by 2 is equals to 4. In third iteration, I equals to, now the current value of I is 4, right, because we are also storing the value I, the resultant back to the I. 4 multiplied by 2 is equals to 8, right? In fourth step, I equals to 8 multiplied by 2 is equals to 16. And I hope you have guessed that there is a sequence in which the value is incrementing, right? So the sequence is, what the sequence is 2 raised to power 2, this is equals to 2 raised to power uh, 2 raised to 2 raised to power 1, this is 2 raised to power 2, this is 2 raised to power 3, and this is 2 raised to power 4, right? Okay, and if I can write this one something like this, or I can, the better is, let me add a column here and insert a column to the right, and let me something like this. So here 2 raised to power 1, right? This is 2 raised to power 2, 2 raised to power 3, this is 2 raised to power 4, right? And every iteration in at fifth step, the value of I will be 2 raised to power 5. The value of I is incrementing, and this is what, this is equals to logarithm. This is log of n. Log base 2 of n, right? The base is equals to 2. Why base is 2? Because here the value is multiplied by 2 every step at 2, right? If we are the value of c becomes 3, then this the base of this log will be 3, right? So that's how this code is working. When we are multiplying, we are incrementing value in every step, and the number of steps this code will work will be the log base of the given base, and then the value of n, log of n. Suppose the value of n is equals to, let's say, 20, right? So how many times, and the value of c is, let's say, it's 2. So how many times this loop will work? Now here we have 2 to the 16, and then 16 to the 32, and 32 is greater than 20. So the number of times this loop will work is 4, right? The number of times the loop will work is 4. I hope you got the point. And if you take the log of the value, then the resultant will be something like log of 20, that is equals to 4. If you take the log with base 2, you will get the value 4, right? So the runtime analysis, the complexity of this code is log of n, right? Log of n. Now in the second case, I've just changed the operator from multiplication to division. Now what will be the complexity of this code? Here you can say system.out.print any value, let's say so what will be the value of the runtime in the complexity of this code? In case of division, and here you can see the operator is also changed. Its starting value is n. The value of I, it will start from n, it will go till 0, go to the 0, and then at every step we are dividing the value with 2, right? Let's say here again the value of n is 20. So what will happen then? Let me take the help from table again, right? So here steps, and here I is equals to I divided by c. So that's step 1. The value of I is 20, right? I is equals to 20 divided by 2, and it's equals to what? It's equals to 5. At step 2, what we have, 5 divided by I is equals to 5 divided by 2. It is near about, it is 2.5. I'm taking 3. And step 3, I is equals to 3 divided by 2, and it's equals to 1 point something. Sorry, it's 20. It's missing. I did make the mistake. So the number of the first is 10, right? It's not the value of n was 20 initially, so that was a mistake. Okay, now here it's 10. 10 divided by 2, we have 5. 5 divided by 2, it's 3. 3, sorry, it's 3, and step 4, I equals to 3. 3 divided by 2 is equals to 1.9, right? So here again the number of steps that we did is again the same. The complexity of this code is again the log of n, right? Why? Because both the complexity of both the code is same. Here we are dividing. In the previous one we was multiplying and was starting from 1, and in the case of division we are starting from n and going till 0. So the complexity of this code is again log of n with the base 2, right? Why 2? Because at every iteration we are dividing it with 2. If in the case it's 3, then that will be the log of base 3. If then at that point we will be dividing at every step we will be dividing the value with the 3. If the value of c is 4, then the base of the log will be 4, right? So here log of n, and you can write it as with base 2, right? I hope you got how we came up with this solution, right? Okay, now look at this one. We have integer I that's starting from 1, and then what's happening is I is incrementing by the power of 2, and then we are adding 1 to the I. So now let's see this one, that how this works. Let me take help from table, because that's using table is helpful to understand. Okay, so we have what we have is, okay, here we have I, and with the power of 2. First we will take steps, and then I with the power of 2, incrementing with this power. So in step 1, what we have, 1 multiplied by 1, it's 1. And step 2, let's say then now the value of I again, okay, the value of I is 2, because we're incrementing it here. So the value of I is 2. 2 multiplied by 2, it's 4. Now the value of I is 3. So 3 multiplied by, it's not multiplication, it's power, by the power of 2. So 3 multiplied by 3 is equals to 9, right? At 4 are 16. At 5 5s are 25, right? So at every step we are the value is multiplying by the power, right? So what is the time complexity? How we can take out the time complexity? Try to analyze the pattern, the incrementation pattern of the value. As we saw in the last slide, we analyze the incrementation pattern, that how the value is being evaluated. It's not the incrementation pattern, actually it's the evaluation pattern, that how the value is being evaluated, right? In the first example we saw that the resultant value is coming something like this, with the power of 2 raised to power. At every step it was 2 raised to power 1, then 2 raised to power 2, 2 raised to power 3. In case of division, when we divide the values, then we were getting some values with the pattern. So here again, try to analyze the pattern, that with what pattern the values are coming coming in. So here we have 1, then 2, 3, 4, and if you see, it's a square root pattern, right? So if I have, let's say, the value of n, if I am taking the value of n is 50, right? Then how many times this value will be printed? Okay, so now 6 are 36, and then 7 sevens are 49, right? Now in case of when the value of n is 50, the total number of times this value will be printed is 7, and if you take out the square root of 50, you will get 7. Okay, let's check it here. Here we have 50 and I'm taking the square root, right? As you can see, 7.07 something. So the time complexity of this code is square root it's square root of n, right? So the time complexity equals to square root of n, right? Again, try to guess the pattern, and then with the help of that pattern, you can easily analyze that how can we take out the runtime, the time complexity of the code.